Salutations. Today we'll be discussing some of the principles of capillary action, namely capillary rise. Let's take a look at our basic equation. So what we have here is H is equal to 2 gamma times cosine theta, which is the contact angle, and that's all over rho gr. And I have all the variables here defined. You can see gamma is the liquid air surface tension, theta is the contact angle as previously stated, rho is the density of our liquid, G is the local gravitational field strength, and R is the radius of the tube. Now for capillary rise, we're generally going to be discussing tubes with a fairly small radius here, and H, of course, is the positive or negative rise of the meniscus within the fluid.
Now, the gamma in the equation represents surface tension. Surface tension is the resistive nature of a liquid. The phenomenon is due to cohesive and adhesive forces within the individual chemicals. This principle is beautifully exemplified in the locomotion of the Gerardae family of insects, or more commonly known as water skimmers. The phenomenon is due to cohesive and adhesive forces within the individual chemicals. Now, when we talk about cohesion, that refers to water molecules sticking to other water molecules. When we talk about adhesion, that is the nature of water molecules tending to stick to molecules of other materials.
The contact angle is the angle between the liquid-vapor phase of a substance and where it comes into contact with its solid phase counterpart. This factor is also dependent on cohesive and adhesive forces and thus closely related to the surface tension.
One of the final parameters of the capillary rise equation is rho, also known as density of the liquid. Density is simply the measure of a substance mass per unit volume, as seen below in the following image. Many different substances have different densities.
So let's actually throw some numbers up here on the screen and examine how the different components affect fluid rise. As shown on our slide here, we have water and mercury in glass tubes, and for the purpose of this problem, we're going to be discussing glass tubes of radius 0.2 millimeters in size. Now, that's fairly small, but as we discussed prior to this, capillary action actually takes place in very small radii of tubes. So we have water on the left, mercury on the right. When we run through the numbers here, we see that mercury is far, far greater. We're talking it's 13 times denser than water. And that actually shows up in the inverse relationship for this equation. You see densities on the bottom, so the denser the fluid is, the less you're going to actually see in height rise of the meniscus. The contact angles are different, of course. Mercury and water are going to have different chemical features when we discuss adhesion and cohesion.
Capillary action can be found in nature as seen by trees taking water from the ground and moving it up through their roots and to their leaves by the use of capillary action.
So one of the other things I just wanted to discuss in this short video are some of the products that we actually use every day that utilize capillary action, and we don't really realize their benefits. So the first group I want to discuss are just kind of ceramics and paper products. Both of these, both very absorbative. Obviously, paper products are. If you didn't know, ceramics and a lot of other masonry/brick type things also have a sorptivity constant, meaning they do absorb liquids and others. Sponges and spill socks. Sponge, same kind of principle. Spill socks are actually used in labs or environmental cleanup of oil spills on a larger scale, of course. You know, they have a big spill sock that kind of wipe over the water. And finally, the one thing I wanted to cover is kind of an overlooked one, capillary tubes. Now, literally, this is the equation we solved, but what you take for granted is the fact that it minimizes the amount of blood needed to take in for a sample by a phlebotomist. Also, by creating a smaller diameter and stretching it out, you're making it much easier to see through to perform light tests on, to detect certain levels of different chemicals in blood samples.
Well, I hope you folks enjoyed yourselves. Catch you later on down the trail.